Hello and welcome to Higher Algebra. We'll get going here with our very first topic, which is order of operations and the distributive properties. So these are just reviews of a couple of algebra topics you perhaps have come across in your Algebra 1 class. A couple things here for class. Just make sure you have a charged iPad. If you have access to a T83 or 84 calculator, that would be very helpful. I also put on to Schoology Updates an online calculator that you could access. Pencil and notebook are mainly if you decide to take any notes or show any work on notebook paper, if you don't do the work on your iPad. And then finished homework, just any assignments that we had from a previous class period to bring ready to class. So as we get going here, greatest enemy of learning is knowing, John Maxwell. First topic, order of operations. This PEMDAS is something you've seen in the past. Again, please excuse my dear Aunt Sally. Sorry about that picture there. But you have parentheses, again, is the first thing you would do in an equation or compute in an equation or simplify. Exponents would be next. And then multiplication and division are side by side because you just do those left to right. So it could be division first, then multiplication, depending on the order of the equation. And then finally, addition and subtraction occur last. Here's an example. This problem actually went viral because there was a lot of debate about what the actual answer was. And the issue with this is it's written ambiguously, which we will not do to you. But the way we would do this problem is we would have 8 divided by the 2, and then the parentheses go first, so that would be 4. Okay, and now when we look at this, we have 8 divided by, and then there's a 2 times 4, and it looks like, the parentheses, that maybe that 2 times 4 gets the priority here, but that 2 times 4 is just a multiplication problem, so it's really division and multiplication now go left to right. So the 8 divided by 2 happens first, and then we multiply by the 4. So the answer here would be 16. There was a time in history back in the 1910s where actually this problem would have been looked at a little differently, and we would have done that multiplication first. And so it would be 8 divided by 8, or 1, but we'll have it be 16. And again, we won't do something to this like this to you. We'll make the problems look come across clearer. So here's a couple of examples, and again, there's a little recap up top of the process of order of operations. And so looking at these examples, and I'm going to, actually I'll stay sideways since it's not going to get bigger, but looking at 4 plus 3 squared. So there are no parentheses, of course, but there is an exponent. So the exponent would go next, so this would turn into 4 plus 9. And that 4 plus 9 then, naturally there's only addition left, so that's just 13. So it's a pretty quick one. Now moving over here to example number 2, again, we now have some parentheses, so we'll worry about those parentheses first. So that's it's a little too light for me. So we've got 4 plus, and then let's finish those parentheses first. So that's going to be 2 plus 1 is 3, and that's squared. So parentheses are done. Now we have the exponents. Okay, so that's the exponent in this case is the squared, 3 squared. So that's 4 plus 9, or 13 again. So as you can see, very similar questions. It's just one of them has a parenthesis that occurs first, and then we still work through the exponent and then the addition. A little more involved here on this one. If we look at example 3 here, and looking at example 3, so we have a parenthesis inside a bracket. So that just means we're going to work inside out. So we've got 4 plus, and then we keep the bracket, 3, and then there's this 4 in the parenthesis. Close the bracket, and then square. Now what the bracket does, it just shows that we're going to square that whole inside the bracket. So let's finish computing inside the bracket, which can act as a parenthesis here. So this would actually be 4 plus, and then in the bracket now is 12, because 3 times 4 is 12, squared. So that would be 4 plus, and now we get to the exponent finally, and that exponent is 12 squared, so that's 144, which brings us to an answer of 148. So again, we dealt with the parentheses first, which in this case we had a parenthesis inside a bracket, or kind of the equivalent of saying a parenthesis inside a parenthesis for us, and we worked inside out, and then we got to the exponent and squared, and then again we just added. Now example 4 here, this is a little different. This fraction bar actually also acts like a bracket. So the way we would read this really is 20 plus 5 times 5 in one bracket, and then divided by, and in the other bracket it's 3 plus 6. So we basically treat these, the numerator, the top of above the fraction bar here is one formula, and then we treat the denominator below the fraction bar as one formula, and then at the very end we divide. So the division is still like in the division in PEMDAS, but because of that fraction bar, we treat the top and bottom as being kind of separate parenthesed problems. So in the top here, we've really got 20 plus 25, and in the denominator we have 9. And 20 plus 25 is 45, so we really have 45 over 9, which is an answer of 5. Okay, so that's some order of operations problems there. You'll get a chance to practice some of these here short. Second part of this is the distributive property. A distributive property is the idea of distributing a value across the parentheses. So what you're going to see here in this distributive property is, if I zoom in a little bit, what we're really doing in all of these is just taking and multiplying that value that's outside by both of them inside. Now, these will be there'll be different types of values. There may be a variable in there. If it was just a 3 and then a 2 plus 4 here, well, then you'd probably just add the inside first, and it would just be 3 times 6. So you wouldn't really distribute in that case. But you could take 3 times 2 and 3 times 4. So that would give you a 6 and a 12. And you'd add those up and you'd get 18, just like we got right here. So typically the distributive property will be used when we do have a variable in play. But the way we'd look at this then is this is really AB plus AC. Okay, and then if they're like terms, meaning they both have no variable or they both have an X, then you can combine them. You do have to be aware if there's a negative. So this next one would be A times a negative B, so that would be negative AB plus AC. In the third one, the negative goes with the C, so this would actually be AB plus a negative, plus a negative AC. And I'll just write it like this, minus AC. Or you could do plus a negative there, would be the same thing. In the fourth one here, now we've got, change colors here. Now we've got a negative and a negative, and so the negative and the negative, a negative times a negative is a positive, so that actually goes back to AB, and then minus AC. This one here, we've got a negative times a positive, so that's a negative AB, and then a negative times a negative, so that's a plus AC on that one. Now, this last one can be the trickiest for folks where there's just a negative up front. Now, keep in mind that negative is like a -1. So -1 times B would just be negative B. -1 times a negative C, again, negative times a negative, would just be a positive. So if you see a negative out front, just remember to treat that like a -1, and all it does is it changes the sign of the values inside those parentheses then. So B was positive, now it's negative right here. C was negative, now it's positive right here. So keep that in mind. Looking at some examples here just really quickly. So here you can see there's variables in play with some of these terms. Um, for instance, to start here, we've got 3 times x, so that's just 3x, and then 3 times a negative 7, so that's a negative 21. So that would just be minus 21, or plus a negative 21. Second one here, we've got the negative 4 times a negative 7, so a negative times a negative is a positive, so that's 28. Okay, and then we've got a negative times a positive, so that's going to stay negative then. And again, 4 times 4 is 16. The negative makes it negative 16, and then we have the x. Okay, so that would be minus 16x on that one. Now this third one, this is the last one here for this lesson. This one will take a little more work because we're going to distribute first, but then we also have some like terms to deal with. So again, we treat this as a negative 1 here. So that's like a negative 1. So negative 1 times negative 5x makes that a 5x. Negative 1 times the 17 makes that a negative 17. But then we still add 7 and subtract 3x. Okay? Now we have to think about our like terms. So the like terms here would be the x's. Okay? So we have a positive 5x and a negative 3x. So it's 5x minus 3x, which is like saying 5 apples minus 3 apples. And we have 2 apples left, so we just have, in this case, 2x left. So that would be 2x. And now with the other side of this, we look at, there's a negative 17, and then there's a positive 7. Okay, they are like terms, neither of them have x's. And so we look at what's negative 17 plus 7. Well, that's a negative 10. So that would be 2x minus 10. And there you go. There's your answer, 2x minus 10. Now, no more solving here because we don't know what these are equal to. We can't solve for x yet or anything like that. So, so we leave it at that. Thank you for watching. Thanks for listening. As always, if you have questions, please make sure you ask. Thank you.